Look, I've got some slides. I've got some slides to share, so I'm going to get those up in a second. It's a terrific topic. We have been running the specialisation of biomedical engineering as a dedicated engineering program just for a couple of years, and the demand is off the charts. We're doing really, really well. There's a lot of interest. The intersection of technology and engineering is a catalyst, and it's really an exciting time for us to be in the space. So without further ado, let's get these slides up, and I'll tell you a little bit more about what the world of biomedical engineering at Monash entails and why it's such a great discipline as we look to the future. So are you getting a full screen now, Peter?
Yes, I am. Very clear.
Thank you. Thank you very much.
Thank you.
So when we think about what's coming, of course, it's a little hard to envisage. We can only really imagine, but we do know that our lives are constantly changing and that the workforce is evolving. And we get such statements as this made by Morris Myslowski, who is a business futurist, that over the next 35 years, 60% of us will be doing jobs that don't exist now. Biomedical engineering is in its infancy, I think. It is the intersection of a few areas of engineering and biomedical science. And we only foresee that the way is up insofar as its development and evolution. So let's take a look at what biomedical engineering is. So combining medicine and technology, obviously. When you study at Monash, it's going to be involving streams of electrical engineering, as well as chemical, mechanical, and materials. So in that sense, it's actually multidisciplinary. And we see other areas of engineering in the same light. The new innovations in aerospace, which combines mechanical engineering and materials engineering, is another area. Robotics and mechatronics brings together electrical engineering and mechanical engineering. So that intersection is increasingly significant to the world of engineering, and biomedical is a classic example of that. So you're going to be looking at inventing and designing and building, manufacturing new types of diagnostics, monitoring tools. You can imagine a lot of these applications occur in a health or hospital setting, but even imagine your Fitbit. That has monitoring technologies built into it, such as looking at how your sleep patterns are and what your heart rate is, and it's all around us now. So 3D printed body parts is an example of biomedical engineering, cardiac pacemakers, 4D ultrasounds. You can see some of the other aspects there. So pretty exciting stuff. And of course, it's all working towards achieving better healthcare outcomes. And there's some really incredible stuff happening as well that I'm going to touch on in a couple of slides. So in Melbourne, we actually are a hub for biomedical science and innovation. At Monash University, we have the Biomedical Discovery Institute, just as an example. And that focuses on things like neurology, cardiology, on treatments such as cancer and the like. And we have companies such as CSL, which is a large innovator and producer of vaccines. So CSL has been responsible for the production of vaccines for COVID in Australia. And of course, not only for Australians, but their distribution to Asia and other parts of the world. Invitech are another company that are involved in diagnostics. Blamey Saunders is involved in developing technology to help people hear. And then, of course, you've got the Monash Vision Group, So the Monash Vision Group are very important and a great demonstration of the power of biomedical engineering. They have developed a technology and system that is going to provide vision to the blind. So this is not people with impaired vision, but people who are blind. And I'm going to talk about that a bit more now in the next slide. So this is, in a nutshell, what it looks like. So a person who may not be able to see can wear these glasses that have an embedded camera. And the glasses are able to take in the field of view and translate that into an electrical signal that gets processed via the headset and is transmitted wirelessly to a cortical implant that sits on the back of the brain. So this is technology that is connecting to the physical human body, and then these signals send what they call phosphine maps, and the brain processes those signals, and you can get a rudimentary image of what is being processed through the glasses. So it's pretty incredible stuff. I mean, to me, it's really science fiction. But at the Monash Vision Group, this is a technology that is becoming a reality, and they have been developing this for 10 years, and in that point of their trajectory where they're wanting to do full human clinical trials. So really exciting stuff.
Sounds like it,
So,
Jamie.
yeah, it's incredible, Peter. And it's amazing to be, in a faculty where this is actually going on. So yeah, really exciting stuff. So if you were, for the students who were considering the study of biomedical engineering, you're going to be doing our common first year in engineering, but there's a slight modification because you need to take a unit that studies cells and tissue. So you have to understand the basics of human biology. And the focus for the degree in years 2, 3, and 4 will be on medical devices and various innovations. Within the cells and tissues, you're looking at molecular biology, neuroscience, which of course pertains to the brain, and cardiovascular, which is our heart, and that's going to give you a foundation for then pursuing the study and innovations in medical devices and the like. So just stepping back from getting to that point where you're going to have a device, you're going to have to understand the way computer programming works, of course, electronics, signal processing and the like. And then, of course, we're looking at implantable devices, general medical instruments and the like. So some pretty exciting stuff. Now, I just want to spend a quick minute on what it looks like for the course map. The course maps are public information that are available on our website. I always encourage our engineering students to compare and contrast what we do at Monash versus other universities, looking at a group of 8, such as University of Melbourne or Uni Sydney, UNSW or UQ, to get a better understanding of where the commonalities and differences are. So for biomedical engineering, you're going to do a common first year, as I said, and the only differentiating unit is the cells and tissues and organisms unit that is delivered through our Faculty of Medicine, Nursing and Health Sciences. Then you've got a range of multidisciplinary units that you'll study. You're going to be looking at these group of units that will encompass biomedical science, so things like body systems and physiology and cells and human development. But then you can see in the latter years, you're going to be also taking in sensors and artificial perception studies. You're going to be looking at medical instrumentation, neural networks and deep learning. So some pretty cool things that are going to enable you to be a biomedical engineer. And then, of course, when we think of engineers, we look at them as being problem solvers and being able to design solutions. You know, that design thinking is very important to the world of engineering and what we try and develop in our students. So you will be able to take on a design project. You've got a final year project that acts as a double unit. Now, there might be an aspect of biomedical engineering that really excites you. It might cross over into software or into a device or into materials. Doesn't matter what your interest is. We have a free final year project for our engineering bachelor students, and we encourage students to have a blue sky approach and make the most of having a fully free option for them to pursue this project. And then, of course, students will be required to do continuous professional development. So that is a part of the Engineers Australia requirements. But of course, at Monash, we help students through that journey. And the beauty of continuous professional development is that students get connected to each other by working in teams on projects. We have a fantastic array of teams and clubs that are connected into industry, connect to our companies that our students go to, so therefore our alumni. And we make sure that our students not only get a great formal education, but they have the applied learning and get connected to industry so that when they graduate, they're eminently employable. That's really where we want to be at the end of the program. Now, we are a research university, of course. The research is very important. It brings us great academics, it brings us funding, we're able to build infrastructure, and we have some brilliant centres of research excellence. We have institutes that provide consultancies, whole range. This is just one of them, of course, and it pertains to biomedical engineering, translational research, of course, that intersection of disciplines, including medicine and IT and design is very, very important. And you can see some of those clinical research areas, including neuroscience and vision. I just touched on Monash Vision Group, of course, cardiovascular and pulmonary, and therapeutics and regenerative medicine. The regenerative medicine is what the fish are about, by the way. So they're zebrafish, and if you cut their tails, then they have the biological and chemical capability to regrow their tail. So we're really interested in zebrafish and the processes that enable them to regenerate a tail. So yeah, pretty interesting stuff. Now, I talked a moment ago, Peter, about the teams and the clubs, right?
Yep.
And so we want the students to really take on the opportunities that the teams and the clubs present. And, you know, if you're doing biomedical engineering, but you still love motorsport, then that's okay. You can still sign up for the motorsport team. But probably the team that speaks most closely to biomedical engineering is the young medtech innovators, and they engage in a range of projects. They developing systems through telephone for diagnostics. They're helping children to have better sleep patterns. There's a whole range of activity that they undertake. They compete with other universities in challenges, and they do some really, really cool things. And this is a great way for students to build those CPD requirements that sit outside of their formal study program. So another thing that we encourage students that are taking biomedical engineering at Monash to do is get involved in our summer research program. the field of biomedical engineering is inherently of a research type. And so we find that students that come into biomedical engineering may want to graduate and get out into the world and get into manufacturing and design. But of course, there'll be a lot of areas that are seeking to advance the field of biomedical engineering, such as the Monash Vision Group, where it'll be more research oriented. And so this is a great opportunity for a student to experience the world of research. You'll take on a 12-week summer internship. You'll be paid a scholarship. You'll be connected and supervised by one of our Monash academics, working on an agreed and designed project. And it's really a fantastic opportunity to get a bit more of a closer look at the world of research. Now, there will be aspects of research in the final year project, in the initial phases of the development of the project, but this is just a pure play research program. And we think a great way for students to see whether that's a trajectory that they want to take once they graduate. So, some of the biomedical devices. Well, you can see on the left of the slide there, they are the cortical implants that go into the back of the brain for the Monash Vision Group. And you can see the Genaris headset there that is connecting the human with the glasses, with the camera, and the signal that gets processed and then transmitted into those cortical devices to create that image on the brain. Really brilliant stuff. Of course, you can see that is an artificial heart in the bottom left, pretty incredible. Different structures in the middle bottom there for bones. Of course, as we get older, our bones get a bit more creaky and frail. And in some cases, people aren't able to walk because of problems that they have in their knees, as an example. And so, you know, the intersection there of materials and biomedical engineering is quite significant to the development of alternative materials that are going to help keep people mobile. And you can see some implants there that are helping people with hearing. So Cochlear is a common name in the world of hearing devices, and Monash has been associated with the development of cochlear implants. They went commercial. Another area that Monash has been involved in closely is in vitro fertilization. Again, it was spun off and has become a private company providing fertility solutions to families. So there's all sorts of incredible things that go on in the world of biomedical at Monash. So it is, as I said at the start of the presentation, a very rapidly evolving career. Plenty of opportunities for students who have an interest in biomedical engineering. Of course, we've talked about equipment and device design and manufacturing. There's some incredible things going on in the medtech entrepreneurship realm. And Elon Musk's Neuralink is a classic where it's trying to get signaling in the brain to create movement of computer software. So some pretty cool things going on. Biomedical instrumentation, healthcare services, research and development. As I was just talking about earlier with Monash Summer Research, it is an area of development and innovation, and that ties in closely with research. So really, yes.
No, because this is very relevant information, because this is often a question that parents especially often would like to know. You know, what are the possible career outcomes? You know, what type of jobs can my child get? So I think this is something that's really relevant and useful, for sure.
Yeah, absolutely. And I mean, look, Peter, we know what a civil engineer is pretty well. We know what an electrical engineer is, and some of those chemical engineers. This is obviously more, it's new and evolving, but I think that as we move forward as well, it's going to become more and more common, and the opportunities are going to grow alongside its evolution. And yeah, it's important that that we foresee that when young students graduate, that there are opportunities. Encourage them to search even on job boards. You go to seek.com.au in Australia and punch in biomedical engineers and see what comes up. You'll be quite surprised. There's a lot of opportunity. And remember, the job boards are the last call for finding people with those expertises. Once you're in a company or you're in the industry, there'll be lots of movement within it as well that you'll never know about on the job boards. So it's a fast-growing area. So look, I just wanted to, I've given our students this afternoon a bit of a taste of what biomedical engineering at Monash looks like. Just want to touch on a couple of other things about the study opportunity, and then I can take any questions. As I said, we solve problems and design solutions, and our researchers are working on all sorts of innovation, and you can just see some of those things there. It's a pretty exciting world, not just in bio, but in addressing problems such as energy. You can see we've developed a chip for the world's fastest internet. 1,000 high definition movies, Peter, in 1 second can be downloaded with this chip.
Okay, wow, okay, that's really fast. Okay.
Yeah, that's really fast, isn't it?
Yeah.
And of course, automation, mechatronics. There's a lot of great things going on. We've got a new common first year, so a bit of an emphasis on the theme of smart cities. And so we're looking at structures, there's some materials within that, design, software and electrical systems, computing and maths. So if students are still not sure about biomedical engineering, Peter, we've got 9 other specializations. Everyone comes in and does the common first year, and then they'll get a better understanding of the world of engineering and what's pushing their buttons. So we've got a whole range of programs that are getting students ready for the workplace as well. We've got a co-op internship. We've got the WIL graduate program. I mentioned the summer research, and we've got career capability skills. So we want students to understand that there's plenty of engagement to get them ready for the workplace and to get them connected to companies. So our engineering and teams and clubs, probably our superpower. It's really what we do best. For biomed, I talked about the young medtech innovators, but we've got a whole range of other programs, including our new team that won $250,000 from the Elon Musk Foundation to remove carbon from the atmosphere. So really, really great stuff. And that's it. So I just wanted to touch on those few things, Peter. And of course, if we've got any questions, I'm happy to take them.
All right, thank you very much, Jamie. For the participants who are still in the session, if you do have any question for Jamie, feel free to type it into the chat, and we can basically discuss it online. We still have a bit of time before we move on to the next session, so feel free to ask any questions. And should, let's say, you want to have a separate session, maybe an individual session with Jamie, you can always fix an appointment with Jamie, and I've kind of listed that information down in the chat too, where you can
absolutely.
Yep.
Absolutely. And also, Peter, I'll just, if students are interested in asking me further questions post-event, then here is my email address as well. I'm happy to take individual requirements. So for entry, so in Singapore, mostly A levels, right? So we're looking at, so we convert the alpha score to be a numeric score at Monash. So an A equals 5, B equals 4, C equals 3, etc. And you need a score of 11, and you will need to meet the English requirement. Now, for the subjects, you're going to need maths and either physics or chemistry. If you've got both, that's great. But students will need an A and a couple of Bs. They're going to need maths and physics or chemistry, and then that's it. They are good to go with that score of 11. For IB level maths, you will need a 4 for standard, and you'll need a 3 for higher level. Okay. Thanks, Cassandra, for the question. Shirley, thank you. And for any other entry requirements, please talk to Peter and the team at IDP, and they'll be able to help you as well.
That's right. Thank you, everyone. We are going to be heading over the time over to the next speaker for the next seminar session. Jamie, thank you very much for sharing what you shared today, because I learned a lot myself today. So
good, Peter.
That's always helpful. So for those who do want to speak to Jamie, you have his email address as stated in the chat at jamie.jobson@monash.edu. And if you want to fix an appointment to speak to him, you can do so, or you can always find any other counselors, including myself, to discuss further about the application process. So if there's nothing else, thank you, everyone. Thank you, Jamie.
Thank you, Shirley. Thank you very much, Peter. Appreciate it. And take care, everyone.
No worries.
Bye.
Thank you very much.